Hello and welcome back to Nunley Math. I'm your host, Aaron Nunley. Thank you so much for joining me here today for part B of our lesson on ratios, rates, and unit rates. Hopefully you've already watched the first lesson where we introduced the idea of a ratio, a rate, and a unit rate. Things were starting to get just a little bit long, so we split it into two separate videos, and this is the second part. If you have not already viewed the first lesson, you might want to go ahead and check that one out. I have included both a QR code as well as two web addresses that will all take you to that same link. For us today, we're just going to dive right in and wrap this up. We're going to look at unit rates for just a moment. Notice I have a problem given. It says Samya reads 182 pages in 3 hours. How many pages does she read per hour? A rate is a comparison between two different items. In this case, we're comparing pages and hours. Pages and hours, those are our two different items, and we're going to compare those using division. Notice the item that comes first, the pages, goes on top, and the hours goes on bottom. And when we want to write this as a unit rate, what we're saying is how many pages does she read in 1 hour, or how many does she read per hour? If she reads 182 pages in 3 hours, then we can divide 182 by 3 to discover how many 8 pages she can read in 1. 60 2/3 pages in 1 hour. And then we've talked in the previous video about the fact that if we're saying pages for 1 hour, instead of using this division bar, which is a little bit clunky, we do it using this phrase and the word per, the numerator per 1 of the denominator. So that's a review of unit rates. Now the reason we like unit rates so much is unit rates allow us to make comparisons when more than one rate is given. For example, if I were to find that a 256 gigabyte flash drive costs $18 and a 32 gigabyte flash drive costs $2.30, which is a better value? Well, certainly $2.30 is less money than $18, but you get a whole lot more gigabytes or a whole lot more space for your $18. It's very difficult to determine which of those is a better value the way it's written. However, if I were to take the $18 for 256 gigabytes and write it as a unit rate, I can divide 18 divided by 256 and I can see that it costs about 7 cents per 1 gigabyte. That's 18 divided by 256. That's going to cost me about 7 cents per gigabyte. And if I take the $2.30 and divide it by 32 gigabytes, here again, this is a rate, and I write it as a unit rate, I can see that it's about 7.19 cents, $0.0719 per gigabyte. When I compare these two, notice that 703 is smaller than 719. This is a cheaper rate. In other words, even though the 256 gigabyte costs more dollars, the cost for each gigabyte is less if I buy the larger flash drive. Now, it was hard to see when they were just written as rates, but as soon as I calculated the cost for one, it's very easy to determine which is the better deal. Now, remember from our last video, I said that typically we put money on top. We could have written this as 256 gigabytes for $18 and 32 gigabytes for $2.30, and then your answer would have said how many gigabytes you get per dollar. Gigabytes per dollar. And the better deal would be the larger number because we want more gigabytes per dollar. So the way we write this is very, very important. That's one of the reasons why we're so conscientious and careful about where our labels go. Now, my suggestion to you is that you pause the video, you try this next example on your own, and then you restart the video to see if your work matches mine. If you feel fairly confident, you can certainly skim ahead to where I reveal the answer, and if you match, you don't need to do that. But if you feel like you're uncertain, certainly watch as I explain. I'm going to assume you've already done that, and I'm just going to go ahead and work the problem out. Alex spends $12.50 for 2 pounds of almonds and $23.85 for 5 pounds of jelly bean. Which item costs less per pound, and then by how much? Notice when you see this phrase cost per pound, that is an indication that you're looking for a unit rate and that cost should be on top and pound should be on bottom. So my almonds are $12.50 for 2 pounds. The jelly beans are $23.85 for 5 pounds. Using division, $12.50 divided by 2 is $6.25 per pound. Remember, that's per 1 pound. Jelly beans are $4.77 per pound. Remember, that is per 1 pound. And so you can see that the almonds clearly cost more and the jelly beans cost less. The question is, which costs less? So the answer would be the jelly beans. Notice the second part of the question says by how much? Well, we'll just subtract those two and we'll see that the jelly beans are cheaper by $1.48. That wasn't too bad, right? Try this one. An online music store sells 15 songs for $12. Another online store, music store, is selling 10 songs for $9. Which online store has the lowest cost per song? Notice, cost per song tells me cost is on top, songs are on bottom, and because we're using the word per, they're telling us they want it written as a unit rate. Again, pause the video, try it on your own. I'm going to keep going, assuming you've already done that. The first store sells $12 for 15 songs, or it's 80 cents per song. Store B charges $9 for 10 songs, which is 90 cents per song, which means the 12 for 15 songs is cheaper by, it says by 80 cents per song. That's a little typo. It's cheaper by 10 cents per song. I'll make that little correction there. It's cheaper by 10 cents per song. Not too bad, right? One last thing that we need to talk about before wrapping up our lesson on ratios, rates, and unit rates is this, something referred to as a derived measure. Derived measures are measurements that are created or derived by finding the unit rate that compares to other measurements. For example, if I have a unit rate describing distance compared to time, that unit rate is referred to often as the speed. For example, if I said 400 meters in 70 seconds, and I were to write that as a rate and then divide that into a unit rate. Meters per second is the unit rate, but sometimes we just refer to this as the speed. And it is 5.71 meters per second if you want to use the abbreviations. Be careful when using these abbreviations. Meters is always abbreviated M, seconds is always S, and per is sometimes P. So I can do this. We don't make up our own abbreviations. We only use those that are generally accepted by everyone. If I use the term density, I'm comparing the mass an item has compared to its volume. So if an object weighs 40 kilograms and has a volume of 10 cubic centimeters, and I write that as a rate, kilograms over cubic centimeters, and I turn that into a unit rate. Notice it's 4 kilograms per cubic centimeter. I just simplified the fraction, and then I write it using the word per. Instead of describing this as a really long kilograms per cubic centimeter explanation, I would just refer to that as the density. And there's some abbreviations for you. Slope is also one you're going to see a lot. You'll remember in the previous video I talked about how this relates to linear algebra. This term slope becomes very, very important for us, so keep that in mind. It's the ratio of the rise of an object compared to its run. So if a plane ascends or goes up 15,000 feet over the course of 50 miles, your ratio or rate, I apologize, is 15,000 feet per 50 miles. Rise over run, or 300 feet per mile. Notice I did not put FPM because those are not generally accepted abbreviations. I put feet per mile. Notice that sometimes we do use this instead of the word per. Not awful, right? Tell you what, take just a moment, see if you can figure out what the ratio or rate for each of these would look like. The speed limit is 45 mph. Do you know what mph stands for? Hopefully you realize that's 45 miles in 1 hour. A computer hard drive rotates at around 7,500 hertz. Hertz is a derived measure. It's a unit rate. Do you know what that one is? Most of the time people are less familiar with that one. Hertz is revolutions per second. Revolutions per second. How many times the hard drive disk rotates in a second. The density, we know this one, of water is about 1,010 grams per cubic centimeter. And a full scuba tank has about 300 psi of pressure. Do you know what pressure is, psi? That's pounds per square inch. Pounds per square inch. A lot of times when you're given application problems, you're going to be given these little buzzwords: hertz, density, psi. And it's important for you to be able to recognize that those are just shortcuts or abbreviations for each of these rates. So, last question. On a trip from Columbus, Ohio to Myrtle Beach, South Carolina, Eliza drove 864 miles in 14 hours. What is her average speed? Notice in the question they use the word speed. As soon as I see speed, I think back to, oh yes, speed is distance divided by time. Speed is distance divided by time, or in this case, the speed is 864 miles in 14 hours. Her speed then would be this unit rate. I divide that out, and it's 61.7 miles per hour. Again, I don't think there's anything in here that's overly complex, but it is extremely important that you're careful when you're reading these. A lot of times we get in the habit of reading word problems way too quickly and we miss over a lot of details, especially terminology that has very specific meanings, like the word speed here. If we don't know what that term means, it makes it very, very difficult to do a problem that really, from a computational standpoint, is pretty easy. That's all I have for you. I know this was a lot shorter than part A, but I didn't want that one to get too long. So hopefully you appreciated the fact that this was split up into two pieces. As always, I do thank you for joining us here today. We will have another video following up on this one here very, very shortly, so make sure you come back for that. In fact, if you ring that bell and turn on your notifications and like and subscribe, you'll make sure you don't miss anything new coming out of Nunley Math. As always, I do wish you all the very, very best. Take care of yourselves, all right? Bye-bye.